Welcome to this explainer. Today, we're diving into an invisible but absolutely high-stakes world. Whenever you stream a video, send a secure email, or pull up a cloud database, you are relying on this massive physical web of infrastructure housed inside data centers. But who actually keeps that web from just collapsing? Well, we're going to look closely at the intense apprenticeship of data center technicians, drawing specifically from the rigorous training protocols over at the Etisalat Academy. In this environment, literally a single wrong move, just one misplaced cable pull, can cause accidental service outages that knock entire organizations offline. It is a world of immense pressure, high liability, and absolutely flawless precision.
And the absolute foundation of everything we'll be discussing today is this. Tracing is a process of verification, not guesswork. This Etisalat Academy maxim really sets the entire narrative for a technician's journey. Think about it. When you're standing in front of a crowded enterprise rack crammed with thousands of identical-looking cables, guesswork is your ultimate enemy. A master technician has to operate with the precision of a surgeon. You can't just guess where a connection goes, you absolutely must verify it systematically.
So here is our roadmap for the explainer today. 1. High stakes in data centers. 2. The art of cable tracing. 3. Identifying your physical assets. And 4. The supervised testing phase.
All right, let's jump right into Section 1. High stakes in data centers.
Before we even look at the tools, it's crucial to understand the environment these technicians are walking into. And that brings us to the golden rule. If a cable is not labeled, do not touch it. It sounds simple, right? But violating this exact rule is exactly how massive outages happen. An amateur might be tempted to just tug or wiggle an unlabeled cable to see which light blinks on the network switch. But in a professional data center, no way. Wiggling a cable can cause intermittent link failures on adjacent ports, which immediately triggers unnecessary alarms over at the Network Operations Center, or NOC. Professional tracing is literally like defusing a bomb. You don't just yank a wire to see what happens.
Moving on to Section 2, the art of cable tracing.
So, when a technician actually faces an unlabeled cable, they have to rely on specialized, non-destructive instruments. And the tracing method they use entirely depends on the type of cable they're dealing with. For standard Ethernet or copper cables, technicians use an auditory method called tone and trace, which relies on a tone generator and a probe. But for fiber optic cables, the approach shifts completely to a visual light method. It's a really fascinating contrast, listening for a signal versus looking for a physical light. Oh, and there is a massive safety rule for fiber. You never, ever look directly into the fiber tip. The lasers can permanently damage your eye. You always have to look from an angle or use a piece of white paper to reflect the light.
Now, what's really interesting about this is the specific tool used for that visual method. It's called the VFL, or Visual Fault Locator. When a technician connects a VFL to one end of a fiber cable, it safely injects this really bright red laser glow right into the line. Then the tech simply walks to the other end of the rack or even across the room and looks for that red glow. It brilliantly illuminates the exact path of the correct cable, and the best part is the technician never even has to pull, tug, or disturb any adjacent live cables to find it.
Okay, let's walk through the actual sequence for tracing copper cables, the tone and trace procedure. Step 1 is to safely disconnect the suspect cable. Step 2, you attach the tone generator directly to that end of the cable. And step 3 is really where the magic happens. The technician takes the probe, walks over to the patch panel, or the far end of the rack, and simply listens. The probe picks up an audible tone when it gets close to the correct wire. This sequence is a total lifesaver because it lets a technician seamlessly navigate a ridiculously dense bundle of wires, zeroing in on the exact right cable entirely by sound.
But actually identifying the cable, that's really only half the battle, because documentation is the enemy of the trace. This is a huge pro tip taught at the Etisalat Academy. If you walk onto a site and there's no patching schedule, no map showing what connects to where, you don't just trace your cable and leave. You document it. Master technicians literally always carry a label maker or a permanent marker. Every single time they trace a cable, they label both ends. By doing this, they are essentially fixing the site for the next technician. A well-labeled rack is the ultimate signature of a true professional. Of course, with those best practices comes some very strict warnings. So here are the professionals' don'ts. First, don't yank. Fiber is incredibly fragile. A hard pull can create microscopic fractures inside the grass that cause high signal loss. And the crazy part is, it might not even show up as a failure for weeks. Second, don't overbundle. You must use Velcro straps, absolutely never plastic zip ties. Zip ties can easily crush a cable jacket and completely degrade network performance. And finally, don't assume.
Even if a cable looks like it obviously routes right over to port 1, trace its entire length. Cables are sneaky. They're often routed through hidden paths behind racks or completely out of sight under floor tiles.
All right, let's head into Section 3, identifying your physical assets. So once the cables are mapped out, technicians have to shift from physical tracing to cognitive mapping. In a data center, a technician who can't accurately identify the equipment they're working on is a massive liability. They use the 3-tier identification protocol to cross-reference equipment before they even think about typing a single command. Tier 1 is logical. What's the network ID? You find this house name on the front panel label or web interface. Tier 2 is physical. What is the hardware asset? You'll find the manufacturer, model, and serial number right on the actual metal nameplate. And Tier 3 is contextual. Where's the specific port or slot located on the chassis? For this, you actually have to verify the silkscreen printing directly on the faceplate. Because look, if you report a fault on port 3, but you're actually plugged into port 4, you are going to waste hours troubleshooting a perfectly working port. You absolutely must verify all 3 tiers.
Now, within that physical tier, there's one piece of data that rules them all. The serial number is the fingerprint of the device. The crucial point here is that when a technician is reporting a fault to the Network Operations Center, a model number is basically useless on its own. A model number like ASR 9001 just tells them the generic category of what the device is. But the serial number? That tells the database exactly which specific, unique unit in the whole world is failing.
And just like tracing, asset auditing has its own strict don'ts. First, don't guess. If a piece of equipment is unmarked, never just assume it's old, unused junk. It could literally be a critical legacy system keeping the building's HVAC or security running. If you can't identify it, you do not touch it. Second, don't rely on your memory. Even if you've been to this exact data center 10 times, re-verify those labels. These environments constantly change. Equipment gets swapped out during night maintenance all the time, and your memory might be visualizing a unit that got replaced 3 days ago. Also, remember the golden rule here. If you spend 10 minutes identifying an unmarked device, spend the 30 seconds to actually print a label for it.
Let's transition to Section 4, the supervised testing phase.
This right here is the climax of the trainee's journey, bridging the gap between classroom theory and highly dangerous live-fire execution. Because testing involves injecting signals, changing device states, or even power cycling hardware, the Academy enforces a really strict sandbox-first policy. Trainees literally never touch a live traffic-carrying port during their first week. It is just way too dangerous. Instead, they have to build up their muscle memory and confidence on a lab rack. They practice patching fibers, configuring basic IP addresses, and running those VFL traces we talked about, all in a safe, totally non-impact environment where a mistake isn't going to take a hospital or a bank offline.
Then, when they finally step onto a live site, they don't just start plugging things in willy-nilly. They follow the strict observer-doer protocol. It's a 3-stage handover process. In Stage 1, the observation or shadow phase, the trainee just simply watches the master technician perform and explain the test. In Stage 2, the assisted or handover phase, the trainee performs the test, but the master trainer is physically right there, holding the cable or pointing to the port, maintaining the absolute final yes or no authority before a single button is pushed. Finally, in Stage 3, the verified or checkback phase, the trainee performs the test independently, but the master verifies the result before it is ever reported to the NOC.
A massive part of this supervised phase revolves around this profound concept. Knowing what a bad result looks like is actually more important than knowing how to use the tool. Trainers will legitimately run an error trap drill. They will intentionally sneak a bad fiber patch cord, one with a known high signal loss, into the test rack. The trainee's job isn't just to blindly read the numbers off their power meter tool, they have to recognize that fail state. If they don't intimately know the pass and fail thresholds, they might look at a terrible reading and tell the NOC the link is fine, which would completely sabotage the network.
And because the stakes are so high, the burden on the master technician is just immense. The golden rule of supervision states plainly, if the trainee makes a mistake, it is your mistake. The trainer can never let go too soon. The responsibility for the uptime of that multi-million-dollar facility rests entirely on the shoulders of the supervisor, not the apprentice.
So, to manage that incredible burden, trainers establish a critical safety net, the stop word. In these high-voltage, high-traffic data centers, if the trainer says stop, it is an absolute command. The trainee must immediately freeze, cease all testing, release whatever cable they are holding, and look directly at the trainer. There is no time for, wait, why, or hold on just a second. No questions asked. It is the ultimate emergency brake that prevents catastrophic human error.
Which leaves us with this final question to ponder. Who are the invisible masters of precision keeping your digital world online right now? The next time a web page loads instantly or a video call connects without a hitch, remember that it's not just magic or software. It is the direct result of rigorous discipline, flawless cable tracing, verified asset management, and the intense, supervised training of the technicians standing quietly in the aisles of our global data centers. Thank you so much for joining me for this explainer. I really hope it gave you a whole new appreciation for the physical foundation of our digital lives.